this video, we're going to take a look at how to make a character move inside Unity when pressing the keys on the keyboard. So I have a character here in the scene. It's a prefab, it's already set up, and it has, of course, it has some bone structure, it has a mesh, and it has an animator, which right now has no animation controller. And then it has a script, and that's a script that I'm going to show you that I already made. I'm just going to comment on what I've done. So if I double click on the script, well, if I click simply, I will see the file, and I can double click from here to go into my editor of choice. In this case, it's Visual Studio. The script that I've made is quite simple, and basically it all leans on the update function for now. So looking at the script, when you create a new script, you will usually see the start and the update function. The start happens at the beginning, as the comment is saying. It's called before the first frame update. So as soon as you start the game, start is going to be called. And then update is going to be called once per frame. So as the game is rendering, the graphics rendering, right? So the Unity will call the update function once per each frame. And that's how we make a character move. We read the input and we apply that movement to the character. So how did I do that? First thing, I read the input from Unity's input system, as you can see here, which means that basically I'm tapping into the input system, which is already made for me, which is this class here, and I'm going to grab an axis. So I'm going to ask Unity how much is worth, at that point, the horizontal axis. You see, I pass here the name of the axis. Now, to see these axes, where they are defined, we need to go back to Unity for a second. And the axis, you will find them in here. Edit, Project Settings. This window will open. And then you go to Input. So you can see here that this particular project has already some axes defined. And these are basically the default ones. The only two that I'm interested in here are horizontal and vertical. So if I expand this, you will notice that here the name is horizontal, and this axis is connected to the keys left, right, A, and D. So I can press either one of these, and the axis is gonna take a value basically. So if I press left, it's going to go negative. If I press right, it's going to go positive. If I press A, negative, D, positive. So this is already set up for you. So we have this horizontal axis, and then we have the vertical axis, which of course is like down and up, S and W. So by using A, W, S, D, or the arrow keys, I can valorize these two axes. So I can then go into my script and ask Unity to give me the value, right? And I will get a value which is basically, I'm going to write it here, from -1 to 1. So if I don't press anything, it's going to be 0. If I press left, it's going to be -1. And if I press right, it's going to be 1. And these values like oscillates. So if I release the key, it's going to go back to the 0. So what I do here is I take this value, which is a float. You can see what type it is if you hover on the function. Well, this has no autocomplete, so you're not going to see it. So it's a float, so it's going to be a number. And then I put that number into a variable, into a float type. I do the same for the vertical. So I grab the horizontal amount and the vertical amount, and I use them to build a new vector3. So a vector3 is a variable that has 3 values, X, Y, and Z. And I want to use X and Z, which are basically the ground plane. So if you go back to Unity, actually, you can see here from the gizmos, I'm going to put them on gray. Yeah. So this is the ground plane, right? Like X and Z, which means right and forward. In fact, like you want to see things from this point of view. So that the Z is forward and the X is right. And the Y is going to be up. But we don't care about the Y because this character is only going to move on the ground plane. So when we construct our vector, we will say new vector3, and then we pass the X, horizontal, and the Z from the vertical, and we put the Y to 0 because we don't want any vertical movement. Once we construct this vector3, I also multiply the vector3 by time delta time. Time delta time is basically a value that defines the time that has passed since the previous frame. And this, we don't need to go into too much detail about this, but basically know that like by multiplying anything by this value, you're basically making a game that runs the same regardless of the frame rate. So regardless of whether the game runs well or whether it runs very, very badly, the character is going to move at the same speed. So you don't have any difference in different machines, in different computers. And then I just multiply everything by 2 because I felt it was a bit faster. I felt it was the right speed. So with this, I get the vector of movement, and then I can use it to move the character. And I do 2 things here. One is to, so I also operate a lot on the transform component by just typing transform. From this script, I'm accessing this one here. So I'm going to modify the position, and you will see also the rotation of the character by accessing the transform component. So I type transform, and then I use the translate function and pass the movement vector that I built before. And I also say that like the space that I'm going to use for this movement is the word space. So if you see this gizmo here, that's how the movement is going to be applied. So any amount of X is going to go on this axis, any amount of Y is going to go on this axis. So if I press right, the character is going to move this way. If I press left, it's going to go that way, forward and backward. And that works for me. And then the other thing I'm doing is I'm defining the forward of the transform. So that means that the transform is going to rotate and it's going to orient its forward in this direction. And I'm going to use the same vector so that basically the character is going to look wherever it's going. So it's going to basically look forward, right? So just by doing this, the character will move. I will show you the next line later. Let's try this script. If I press play, I can now press the arrow keys and the character will move around. Now, one important thing to note is that, for example, if I press right, as you can see, the character is going on the right. If I press left, it's going on the left, on the x-axis. If I press down, it's going to go down the z-axis, the blue one, and up is going to bring it up. But this is happening in the scene view. In the game view, I see something different. I mean, if I press up, the character looks like it's going right. And that's because the camera in the game view is oriented differently. So because of how we made this script, one thing you want to check, one thing you need to make sure is that the camera has its Y rotation to 0, because you see the camera is now looking from this side. But by the way we made this, this script, because we're moving in word space, we really need to make sure that the Y-axis is rotation is on 0. So I want to zero out the rotation, and I want to look at the action from this point of view. Now, if I look from this point of view and I press play, you will see that pressing right moves me right, pressing left moves me to the left, down and up. So the keys that I'm pressing correspond to the movement on screen. And that's because the camera has basically no rotation on the Y-axis. If you rotate the camera, then the point is you will need to transform this vector in a way that would be a bit more complicated to explain now. So to keep things simple, we want to make sure that the camera has its rotation on the Y-axis to 0. The other two are debatable, like you can look up, you can look down. That doesn't really matter. And well, you probably don't want to change the Z because that will produce a roll, which is not really pleasant. So I guess Z is also going to stay on 0, but this is the important one. The other step, the last step that I want to show you is to add a little bit of nicety to the movement of this character. So let's say that we want to use the animations that we set up beforehand. So I know that I have some animations here, specifically animation clips, and I want to use an idle, which is here, and the walk animation to produce a change when the girl moves. So to do that, we have a state machine, which we have seen in another video. And this state machine is very simple for now. Sorry, shouldn't be here. This is very simple for now. So it only has an animation clip. That's the idle clip, and one that's the walk animation. Again, if you need to add animations, you can just simply do it by going to your animation files and dragging the clip into the state machine. And that will produce a new state. So let me delete this one again. So we have already idle and walk. And idle is our default state. So you see that it's connected to the entry point. To make a state a default state, you can right-click, set as layer default state, and that's going to be the one that's played first. So right now, the animation is going to go into idle. So let's assign this state machine to the girl. We select the prefab, and we go to our state machine, and we connect it to the animator component. Once we have it connected, and I press play, she's going to play the animation when it's in play mode. And actually, if I press left or right, she's going to move. Now, the only thing that's happening here, that's the reason why she's stopping, is because this animator has the apply root motion on, and I don't want that on. So what I want to do is I want to make sure that when I'm applying this animation, the animation is not driving the movement. It's only driving the basically the rest of the bones. So now, as you can see, I can move around because root motion is off, and she's still playing the idle animation. So now to play the other animation, the walk animation, I just need to connect these states. So I will say that the idle, I want to make a transition to the walk state, and I also want to make a transition back to the humanoid idle state. And now I need to define when this transition happens. So to do that, I will create the parameter that I deleted before. It's going to be a float, and I'm going to name it speed. And basically, here I'm saying there is a parameter that I call speed, and it's a number that can go up and down, right? And then here in the animator, I say, you start from idle, entry point, but you will move to humanoid walk, and then you go here, conditions, when the speed, which is the only parameter, is greater than 0. So as soon as the speed parameter goes above 0, Unity is going to transition the animation to the walk animation clip. And then we select the transition going back, and we say we want the transition to happen in the other direction when the speed parameter is less than, let's say, for example, 0.01. So a very small value, right? So if it goes to 0, which is less than 0.01, it will transition back. If it's greater than 0, it will transition to the walk cycle. Last thing we need to do, in our script, we need to set this parameter here. And that's quite simple. So first you want to grab a reference to the animator. So you want to declare a variable that's an animator type. I gave it the name animator, just very simply. In the start function, I want to grab the reference to it. So I'm going to say that the variable that I just created is, I'm going to use the get component function to get a reference to the animator. So because this script, this whole script is here on the same prefab, by using get component, I can get a reference to the other component. So for example, to the animator in this case. So I do get component animator, and now I can use this variable and I can use it in any function, like for example in the update, and set the speed. So again, to set the parameter here on the state machine, I do animator, set float, because you remember this is a float parameter, right? And I will set the float named speed, which is this one. What do I set it to? Well, I'm going to simply take the movement, so the direction of the movement, and here I need to multiply it because when I multiplied it by delta time, it became very, very small. So I'm going to multiply it back to make it bigger. And then I take all of these and I will say, give me the square magnitude. So give me basically the magnitude would be the length of this vector. So it means that if I'm pressing the keys, movement is going to be valorized to anything. And when I get the magnitude, this means that it will be above 0. And then when I release the keys, the magnitude of a 0 vector is going to be 0. So the speed gets set back to 0, which means that the state machine is going to transition back to the idle. So you will see that now if I press play, this should work. And I press the keys. And as soon as she gains a little bit of speed, she transitions into the walk animation. And if I stop, she stops. Now, the only thing left to improve this animation is because when I transition, Unity waits for the animation clip to finish before transitioning. And that's why you see that delay. If I press play again, actually you can select the girl and you will see here the animation playing. So if I press anything when the animation is still at the beginning, let's do it now. You see that she doesn't transition instantly, but it takes a while. So it waits for the animation to finish. So to improve this, I can go to the transition and deselect has exit time. And now if I press play, the transition will happen straight away. Stop, move, stop, and then she stops way better than before. And this is all for making a character move as an answer to input. So again, using the default input system in an update function, and then applying some math, some vector math, and using it for the translate function and transform forward to rotate. And then finally, we also set the speed of the animator component to be able to transition from one state to the other and back. So we also create that illusion of animation. Last thing I want to point to is that, as you can see, I can go through obstacles, and that's because this type of movement that we've made is purely position-based, and basically we're just forcing the position to be somewhere, and when we force it to be inside of an object, it's just going to work. So it doesn't check for any collision. To check for collisions, we will need to make the movement physics-based, and that's another topic.